Hey, what's up? Welcome back. Patrick here from All Things Mathematics, and moving on to the next example on the test. Here we have to find the equation of the tangent line on this function, the square root of 2x minus 1 at an x value of 5. So just to give a quick visual of what's going on, let's say that this function f of x, let's say that it looks like this. I know it maybe doesn't. It may have a different shape. I'm just trying to show a rough visual so you see what the steps are going to be from a high level before we get into the technicals. So let's say that this is the function here, this root 2x minus 1. And then over here, at this x value of 5, there's going to be a tangent on it, right? Touching the function. And basically, we have to find the equation of that tangent line, which is going to be, because it's a line, it's going to be in that form y equals mx plus b. Now notice here that they give us the x value of 5. They don't give us the y value. So if we wanted to get the y coordinate of this point, we can plug in that x value of 5 in the function. 2 times 5 minus 1 would give us 9. Square root of 9 gives us 3, right? So this here, this entire point would be 5 and 3. And now what we have to find is the slope of this tangent. Okay, and if you remember from the lecture videos, I'm assuming you have watched those at this point. How do we find the slope of a tangent at any x value a? Well, it's basically going to be the same as the instantaneous rate of change at any x value of a. It's basically the difference quotient, right? The limit as h approaches 0 of f of a plus h minus f of a all over h. Now, there's two different ways, if you remember from the lecture videos as well, to find the slope. We could first find the general expression for the slope of the tangent with this a value, so not plugging in that x value of 5 yet, right? So we just find the general expression, and then at the end, we can plug in that x value of 5, the actual slope of the tangent at the exact point that we're going to want. We can also find the slope directly, right? By plugging in that x value of 5 for a right away. So we could do 5 plus h minus f of 5 all over h, and then we would get that numerical value for the slope at that x value of 5 right away. So I'm actually going to do it both ways just to practice the algebra in case your teacher's doing it one way or the other. You can pause the video, try it yourself, see what you end up getting, see if you get the same answer that I'm going to get. But I'm going to do both ways, and then you'll also see how you could use the two different ways to come up with the same answer. So let's do it this first way. So we'll have the limit as h approaches 0, and then what we're going to do is plug in a plus h for the x value. So that would be root 2 bracket a plus h minus 1 minus root 2a minus 1, and then that is all over h like that. Okay, and then what we want to do, actually, you know what, before we rationalize, let's actually simplify inside that first root. I'm going to distribute the 2 inside the bracket, so we'll have 2a plus 2h minus 1 minus root of 2a minus 1. And that's going to be all over h like that. Okay, and then from here, to solve this limit, we have to rationalize, right? Hopefully you recognize what the square roots here. So to rationalize this, I would multiply the numerator by the conjugate. So I would keep those square roots the same. It's just this minus I'm going to turn into a plus, right? And that's going to be root 2a minus 1 like that, all over root 2a plus 2h minus 1 plus root 2a minus 1. All right, we got to keep the numerator and denominator the same. So it's like we're multiplying this entire expression by 1, right? Because the numerator denominator is the same here. We're just going to be changing the format for it. So when we're multiplying this numerator by its conjugate, it's a difference of squares, so all we have to do is multiply the n terms together. So we'd end up with the limit as h approaches 0 of 2a plus 2h minus 1 minus root 2a minus 1 times root 2a minus 1 is 2a minus 1, like that. And that's going to be all over h, and then root 2a plus 2h minus 1 plus root 2a minus 1, like that. And then I'm going to distribute the negative inside the bracket. Notice the 2a's would cancel out and the 1's would cancel out, so we're going to just be left with a 2h at the top, right? So we'll have the limit as h approaches 0 of 2h all over h, and then root 2a plus 2h minus 1 plus root 2a minus 1, like that. Here, the h's cancel out, and now we can plug in 0 for the remaining h's. And so after plugging in that h value of 0, we'd end up with 2 over, the bottom is going to be root 2a minus 1 plus root 2a minus 1. Notice these are like terms here, the same root, so coefficient in front is 1 for both. We can add them into 1 like that, right? And so notice that these would cancel out, and then that ends up being the general expression for the slope of the tangent for this function at any x value of a. This is actually called the derivative, something we'll be covering in chapter 2. And now we could plug in any a value or any x value we want here to find the slope of the tangent at that specific point. So plugging in that x value of 5 here, we'd end up with what? 1 over root 9. And so this is going to end up being 1 over 3. So that's going to be the slope of the tangent. So we have the slope of a line and the point that it contains, so we can easily find the equation of it. Plug in the slope first, 1 over 3 x plus b. Now we have to solve for this b value, plug in the point 5 and 3, so 3 for y. We're going to plug in 5 for x. This is going to be like 9 over 3 minus 5 over 3. If we bring the 5 over 3 over, is equal to b, so that means 4 over 3 is equal to b, so y equals 1 over 3x plus 4 over 3. That ends up being the equation for this tangent line. That ends up being the final answer for this question. And then finally, as I mentioned, I wanted to try to see if we get the same slope using the difference quotient again, but instead plugging in that a value of 5 right away, right? So not at the end into the general expression, but right away into the difference quotient. And this here should give us that, after this algebra, it should give us that m value of 1 over 3 right away. Okay, so let's see what happens. So we'll have the limit as h approaches 0 here, plug in 5 plus h for the x, so that'd be root 2, 5 plus h minus 1, minus f of 5 is 3, right? We already know that that's going to be 3, and this is going to be all over h. So this would be the limit as h approaches 0 of root 9 plus 2h minus 3 all over h, like that. If we distribute the 2 in the bracket, simplify everything, right? 10 minus 1 is 9, and then we have the 2h. And then from here, what I am going to do is multiply this by root 9 plus 2h plus 3 over root 9 plus 2h plus 3, like that, right? We have to rationalize over here. And so what's going to happen is we just multiply the ends by each other, right? So the limit as h approaches 0, this root times this root, that's just 9 plus 2h minus 3 times 3, which is 9. And that is all over h root 9 plus 2h plus 3. And then from here, notice in the numerator, the 9's are going to cancel out, so we'd end up with the limit as h approaches 0 of 2h all over h root 9 plus 2h plus 3 cancel, cancel, like that. And we could plug in 0 for the remaining h right here, and when we do that, we'd end up with what? 2 over root 9 plus 3, which is like 2 over 3 plus 3, which is 2 over 6, which indeed gives us that same slope of 1 over 3. Right? So that's another way that you could find the slope of the tangent, plugging in that x value you want right away into the difference quotient. That general form, the way we did it the first time, for some questions, and there's going to be some questions on this test where you do have to do it that way, because we'll be doing the opposite, finding like a coordinate where we get a certain slope. As I mentioned in the lecture videos, that's also what you have to do. But that other general way is also powerful if they ask you for multiple points the slope of the tangent. So imagine they ask you for at an x value of 5, but then they also ask you at an x value of 7, and then maybe at an x value of 11, right? Then you could just plug in those points right away into that general expression we had, 1 over root 2a minus 1, versus with this way you'd have to do 3 different calculations for the 3 different x values, right? So I usually prefer the other way, but if it's only just 1 point that we're looking at, like in this question, you can also do it the direct way, like this. And that is the end of the video. Hopefully you enjoyed that. If you want to find more videos like this, you can go to my website, allthingsmathematics.com. Over there, all my courses are organized for both high school and university. All the videos are organized by chapter. Also, if you have any questions, you can hit me up. My contact details are also on the website. Enjoy your day, and I'll catch you in the next one. Peace out.